Hi guys, so I tried to figure out how to do this video showing me in the video along with the PowerPoint, and I couldn't figure out how to do it for now, so I just decided to give up and just do the PowerPoint. Um, but the goal is for this to kind of be like a regular class, so I'm going to do a couple of examples and then you guys work some problems out on your own, etc. And I apologize that I'm not there today. It's completely stuff that's beyond my control, and so I'm hoping that doing this kind of keeps us from falling too far behind. So if you guys have any questions, you guys know you can text me, and if I'm able to, I can answer you while you're working on this during class. Okay, so try that, and hopefully I can respond back if you need to, and hopefully you don't need my help because hopefully it's not too terrible for you guys. So what we're working on is function transformations. And so before you continue, obviously you're watching the YouTube video, but if you were to download this online, just make sure you're watching the YouTube video. And next class period, I'll go over any homework questions that you guys have from last Wednesday. So hold on to your homework from Wednesday, and then for today's homework, we'll go over all of that next class period, and I'll answer any questions you guys may have before I take a grade for it, okay? So the first thing that we're going to talk about is greatest integer function, and I kind of mentioned this I think on the day of the test, but I didn't really go into detail. You guys have some questions on your homework that deal with this, and so I'm going to go over them real quick just to kind of help you understand. So if we look at that first one where it says 2.1 and these brackets mean greatest integer, you first want to picture a number line, and 2.1 would be about there on the number line. And so what you're going to do is go backwards to the next integer. So from 2.1, if you go backwards, you get to 2. And so your answer is 2. Okay? If we do 4.7 as an example, that dot right there is where 4.7 would be. So we're going to go backwards. The next integer down is 4, and so that would be your answer. So positive numbers are really easy because you basically just take off the decimal and then that's your answer. Okay? Negatives are a little bit trickier, but hopefully this helps you to see them. So if we start with negative 3.4, that's about here. Same idea, we're going backwards to the next integer. So when you go backwards, you actually get to negative 4. And so your answer to that one would be negative 4. Okay, if we do the negative 15.2, there's negative 15.2. You're going to go backwards, so you would get to negative 16, so that would be your answer. So you can see that negatives are a little bit different because the number actually increments. You're not just getting rid of the decimal, you're actually going back a number. Okay? So if you ever get confused and you can't remember how these work, just draw a number line and remember that you're always going to go to the left. Okay? So if we look at the greatest integer of negative 121, there's that. If we go back to the next integer, you end up back at negative 121 because it's already an integer. So if you're already sitting on an integer, you don't have to do anything. That's the answer. Okay? It would be the same thing with positive 121. You're already on an integer, so that's your answer. Okay? And that's not absolute value. Those are ones. They just look weird. So then the last one, you'll have a couple that are similar to this on your homework. You have the greatest integer of negative 3.2 plus 4. So you want to do that negative 3.2 first. So there's negative 3.2. We're going backwards to the 4 with a really terribly drawn arrow. And so you end up with negative 4 plus this 4 right here, which gives you 0. So if you have something like that, just make sure that you do the greatest integer part first before you worry about adding anything that's outside of it. Okay? Alright, so here are your objectives for today. Go ahead and write them down. On Thursday when I get back, I may just check and be sure that you wrote them. So just make sure you have that, and then go ahead and pause, and when you're done, hit play and I'll continue. Actually, so just real quick to go over this, we're talking about parent functions. You guys know what those are, and we're transforming them. So most of this should be review. The thing that might be kind of new is changing the function transformation into composition of functions, and I'll show you what that is later. But a lot of you might have already done this. So for some of you guys, this may be completely review. If it's not, hopefully it's not too terribly difficult, and if it is, just let me know and I'll go over it with you guys. Okay? So you guys should have this piece of paper. Hopefully the substitute gave it to you. And it's just an FYI, you need to have all of these shapes memorized. These are all the parent functions that you need to know The only exception is that rational parent function, which is over there on the right hand side. But all the rest of them, if I say, what does x cubed look like, you need to kind of be able to sketch it at least, okay? So you need to have a good idea of what all of these look like. If I draw something like this, you need to know that that's your greatest integer function, which is what we just worked on, etc. So just be sure that you're familiar with those. At some point I will give you guys a quiz and you'll need to know what they all look like, okay? So I want you now to look at the other paper that you have where it starts with who are the parents, and this is the paper that you're going to actually be turning in for today. So I want you to go through these 9 questions and you're going to tell me the parent function for each one of them. I'm going to give you number 9 for free. It should look like that, x squared, okay? So go through the rest of them, write out what the parent function is. In a minute I'll put up the answer so you can check, and just hit pause until you're done and then continue. Okay, so hopefully you've got all the other 8 of them done. You should have these answers. On number 3, on your paper I think it says A. I prefer using C because when you actually get to calculus, C is the letter that you're going to see. But really it could be either one. It's just as long as it doesn't have an X, you're okay. Alright, so the rest of them should look like those. So check your answers on those and just make sure that you have them all right. And in case it's hard to see, there is a 3 in the armpit there on number 8. I don't know if that's going to come up on your phones all right or not. Okay? Alright, so now I want you to go down and you're going to look at this graph and describe part. And you guys may use the calculator. They should hopefully be out for you guys. So if you don't already have one, pause and go get one. Okay, and what I want you guys to do is graph each of these and you're telling me how it's changed from the parent function. So for example, how did the square root of x plus 4 change from the square root of x? And I'll give you the first one for free. You should see that it shifts 4 units to the left. So go ahead to the other 4. I want you to write what you see happening when you graph it. And then just hit pause, and when you're done, we'll go over it together. Okay, so these are the answers that you should have gotten. Number 2, I want to go over that with you guys in class, the whole stretching and dilating and all of that. So as long as you see that it got wider, then that's okay. And then in class, I'll go over that in more detail with you guys. You may also need a little bit of help with number 3, knowing which axis it's reflecting over. Hopefully now that you see the answer, you get what I was going for. The same thing with number 4, this one reflects over the y-axis. So we'll talk about the dilations and the reflections when I get back. But hopefully you guys had all the rest of that without any trouble. Okay, so now you should see this diagram. It says Transformations of Graphs Lab. And I left some colored pencils out for you guys. So hopefully they're there as the sub for them if you need them. And each one of these things that you do, I want you to graph it in a different color so that you can see. And you're going to be graphing it directly onto this picture. So I'll do the first one. It says f of x plus 1. And I want to do it, I forget what color I used, but you'll see in a second what color I used. So because the plus 1 is in there with the x, that means that you're shifting the x, which is the horizontal. And remember, horizontal is always backwards, so plus 1 actually means to the left, even though you would think it would mean to the right. So letter A would look like that. So I shifted it 1 unit to the left, and I want you guys to actually take each point and shift them individually. And then over here you can see that I wrote red so that I would know later. So each one of these you're going to do in a different color, and then just label the color that you used along here. Does that make sense? I hope so, because you can't tell me because I'm not actually there right now. Okay, so go ahead and graph the rest of those. Hit pause until you're done, and then when you finish, we'll go over them. Okay, so this is what you guys should have for that second one. It shifted down 2 units. Here is the other one. It reflected over the y-axis, and I'm sorry that it doesn't fit on the graph, but you should still have something close to that. The next one shifted over the x-axis, so you can see it down there in the purple. And then the last one stretched vertically by a factor of 2. So remember, the C, D, and E will go over in more detail in class, but you should hopefully be able to have been able to draw it. And if you look at E, just to give you an idea, you're basically multiplying all of the y's by 2. So for example, this point right here, hopefully you can see my arrow, the y value is 2, so I multiplied by 2 and it became 4. Right here, again, the y value was 2. I multiplied it by 2 and got 4. The x value didn't change. Over here, the y value was 4. I multiplied it by 2 and it became 8. So that's how I got those, okay? We'll do more practice like this once I get back, but I just kind of wanted to expose you guys to it, and then we'll look at it in more detail later, okay? So the next thing I want you guys to do is the square root family, and you're going to be able to use your calculator, and I want you to graph every one of them that you see on there, and I want you to actually use the table function, not the graph function on the calculator, because I want to see the actual points of where you graphed everything. I want it to be very, very precise. So take a few minutes, graph all 9 of those. I don't have the answers up here, so you're on your own to graph them. And just pause, and when you finish, hit play, and we'll go on, and I'll give you instructions for the next part, okay? Alright, so you should have all 9 of those graphed, and we're going to use those now to answer the next questions. So you can see you have this table there on your paper, and we're going to fill it in. And I did the first one. This is the first thing that you graphed. It's negative square root of x. And so if you were to do the function composition, because that negative is outside of the square root, then it would be negative and then f of x, okay? And I actually have a typo on here. Go ahead and scratch that out. That doesn't really make sense there. So you just want the negative f of x, okay? So the way we're doing this is if the negative or whatever is inside with the x, then you would put it inside of the parentheses with that f of x. If it's outside, then you would put it outside. So you're kind of just following the same scheme, okay? If you look at the graph that you did on those grids up there, you can see that the x values start at 0 and then it keeps going until infinity, so that would be your domain. And then what we're doing from the parent function is we've reflected it over the x-axis, okay? So go ahead and do that for the next 2, and then you can check your answer to make sure that you're on the right track. So hit pause until you're done with those 2 that you see there. Okay, so for the next one, you should have gotten this as your answer. The plus 4 is on the outside because it's not in that square root with the x. So you're saying f of x and then plus 4. Your domain is still the same. I couldn't make it with the sign of infinity, but you should have the sign of infinity. So it's 0 to infinity, and then it's shifted up 4 units. And the next one was the same, but with minus 4. It's still 0 to infinity because you're just going up and down the y-axis. You didn't go left or right, and so it's shifting down 4 units. So I want you to go ahead and finish the rest of that table. Hit pause, and then when you're done, come back and I'll continue. Okay, so what you want to do is on that paper that you're working on with that table, that whole classwork needs to be done, and you need to turn that into the substitute, and that's your grade for the day. And then I want you to start working on your homework, which is another paper that you should hopefully have. If you don't, let the substitute know. And as you guys are doing this, I want you to collaborate with your peers. So you should be checking your answers. You should be making sure that they're right. And if there's anything that's confusing, text me, or next class period we can go over it together. Okay?